What we have here is a 2008 Samsung LCD television. It's experiencing a major problem called solarization. And I have a video source set up. This is my my old Sony camera. And we're going to see what the picture looks like. Of course, we'll have to go to the other side to see it. So, hopefully the video source is set up correct, and it is. Okay, good. You can see that it kind of looks like a, well, a solarized image. That's really the only way to describe it. Almost like a negative image, but not quite. To try to get a more head-on shot here, so you can see what we're dealing with. This issue is quite common on a lot of LCD televisions. I know that the Samsungs are no exception. And the solution is quite simple. By replacing the timer controller board, which is basically the panel driver board, it's right under this cover here, we can effectively fix the problem. But wait, there's more. Upon inspection, I noticed that this particular set is suffering from 4 blown capacitors. Well, 3 technically, but the 4th one probably isn't far off. These 3 capacitors are starting to blow their tops. That's a bad sign, but it can be easily fixed. So what I'm going to do, I've already ordered all the parts to fix it, but only the capacitors have come in. I ordered a 10-pack of Nichicon capacitors to replace those 3. Unfortunately, the timer controller, or T-Con board, is coming from Hong Kong, so it's going to take a couple weeks to get it. But seeing as I have nothing else better to do other than watch daytime television, because of this massive snowstorm that is striking the East Coast as I speak. My area hasn't been hit so far. I mean, we've gotten, of course, almost a foot of snow, but we're due for another foot. So it's going to be a long night. I figured, why the hell not just replace those 3 capacitors and see what happens? I mean, it's not really a hard project. All I've got to do is remove the, of course, let this discharge for a little bit. But all I got to do is basically, no residual power there, replace the 3 capacitors by ripping off the power supply board. What the hell? It could be fun. Of course, I haven't tested any other capacitors for issues, but I do know that an unclean power source can cause a lot of problems on a lot of electronics, and those blown filter capacitors could definitely cause some weird things to happen. Besides, they need to be replaced anyway, so why not just get the job done? I've already tried baking the T-Con board in the oven and it didn't do a thing. I didn't think it would because it's not a ball grid mounting issue and it's not a cold solder joint. It's faulty chips on the board. So, I'm going to find my screwdriver here. There we go. Yeah, the board hasn't discharged yet, but you know what? A little bit of electricity never hurt anybody. There is a correct way and a wrong way to discharge a capacitor. I'm going to show you the wrong way. We're going to take a screwdriver that isn't properly insulated, and we're going to just short the 2 leads together like that. That's the wrong way. The correct way is to use, I believe, a resistor, which prevents a spark and can prevent further damage to any other component on the board. The resistor absorbs that energy quickly and without incident. But because we do things the wrong way on BBISHOPPCM, we are going to do that. So these are the 2 main... Oh, I missed one. There's one... I didn't order that one. Or that one. Shit. I gotta go back. I gotta order some more capacitors. I just noticed 2 additional blown capacitors on this board, so we've got to do those too. Yeah, damn it. I thought I could get away with just replacing those 3, but that's just not going to happen. So we've got to take this board off anyway, and yeah. But these two big cans, these are enough to knock you down. Well, not really knock you down, but you'll feel it, trust me. If I were to touch these while they were energized, you would feel it. Well, you wouldn't feel. I would feel it, and it would be very painful, very painful. I've done that before, actually. I burned the tip off a screwdriver that way. Yeah, a lot of energy. But we've got to replace 1, 2, 3, 4, 5 caps with busted domes, or getting there. So this may not fix it. We're going to try it anyway. So the correct way to fix this television, in addition to replacing the T-Con board, would be to replace the entire power supply board. If you didn't do that, the replacement T-Con board would likely fail very soon, or something else might actually blow up on it. But you don't have to replace the entire board. If you've got obviously bad caps and the TV still powers up, chances are you can get away with just replacing a couple of bad caps. I don't think any transistors have blown, or chokes, or any other components have failed. So I think we'll be okay with just those. But we're going to have to continue this video after those other capacitors and the T-Con board arrive. They might even arrive at the same time. It only took me about a couple of days to get the replacement caps. So I'm going to find a place to work. Clean off my cutting board. And we're going to just replace those 3 or 4 caps and move on. When replacing capacitors, you can always go a little bit higher in the voltage and the capacitance, but you don't want to go below it. You don't want to undercut yourself. Then the capacitor will no longer, or at least stretch beyond its limits. There's actually more information on that on the web if you just Google acceptable capacitor replacement specs or parameters or whatever. Alright, so I got to mark off where these are. I'm going to use a magic marker. Mark off where the contacts are so I know exactly where I need to solder. Usually it saves a little bit of time to do that. So we're going to mark off, let's see, right there, and right there. Wait, no, that's not right. Right there. We'll just, damn it, pretend that didn't exist. So, did I get that right? Yeah. Now, the other capacitor, I believe, is of the same value, but it has a different temperature rating. It's 25 volts, 1000 microfarad. And the other ones are 25, 1000, 105 degree, 105. Actually, they're all the same rating, so we're going to do all 4 of them, because I have enough. There we go. Let's do them all. Why not? A real quick word on temperature ratings. The temperature ratings are what the capacitor is rated to operate at for temperature. As the temperature goes up, less rated capacitors can start to malfunction or fail. The higher the temperature means it can withstand those operating temperatures, for extended periods of time. You can go up in temperature rating, but not down. And the ones I'm replacing these with should be about the same. Let's see, 105 Celsius. So we're going to. So when desoldering capacitors, they're the easiest thing in the world. All you've got to do is lift it one leg at a time. You don't have to use any desoldering tools or anything special. Of course, you're going to need the soldering braid later on to clean up the holes, but all we're going to do is melt the solder on one leg while keeping tension on the other side, and that allows the capacitor to move one leg at a time. And then we're just going to put pressure in the opposite direction as we're melting the solder on the other leg. And this capacitor is now liberated from the board. Then we take our desoldering braid and we wick up all the excess solder so that we can slide in the new caps without any trouble. Couldn't be easier. No expensive tools needed. For surface mount work and for IC chips and other things, I mean, having a desoldering tool certainly will help things along. But for this kind of work, there's no need. This is why older electronics are so easy to service, because there's no surface mount components to deal with. Here's the last one. Now this one was made by Sanwa, WHA. The other ones are made by the same company. I don't know why they're different colors. They're the same capacitance, 25 volt. One's a WB, one's an XC, but that shouldn't matter. There are variances in capacitor design, but we're not going to let that bother us in this project. Just get the damn job done. A capacitor isn't a capacitor. You know what I mean? There's different kinds of capacitors for all different applications. But sometimes you can, for something like this, you can sometimes just fudge around and just find something with the same capacitance and get the job done. But let's face it, they used what they claimed to be the right ones, and look how long they lasted, right? So, unfortunately, I don't have anything to put in the spot for those smaller caps. One thing that does matter is that you must ensure that the polarity is correct when you put in the new ones. What I like to do is I first put in all my components correctly, and then I bend the leads apart to hold them in place, and then I solder them. Our new ones are Nichicons, or they're probably fake ones, only because I don't really trust eBay, but they were cheap enough. Now, on a cap, the stripe is negative, but the barrel is positive, so the longer lead is always positive. And boards are usually labeled pretty clearly for polarity. Unless it's made by Apple, and Apple is not really, well, the modern Apple boards are blank. So we did away with silk screening because makes it too easy to service. That's why they do it. Alright. There we are. Oh, I had that in back. No, I had that in right. Okay. Alright. Just spread the leads apart. And the cap will stay in place for the duration of the repair. Alright. Just slide those all in like that. Okay. When I used to do this professionally, I actually worked for a small company doing electronic assembly. I was pretty fast. I was really good at it. But I stopped doing it because it was too mind-numbing, and it was just kind of got old real fast. So now I just fix my own stuff. I'm not an electronics technician by any stretch of the imagination, but I know how to build them. For those of you who own an Anatech Blue ESR meter or an Anatech Blue ring tester, if you bought it in 2007 or 8 or 9, there's a good chance that I manufactured it myself. In fact, I signed the boards of every one that I made. I actually put my name on all of them. So if you take the thing apart and you see BAB on the board, I put it together. Okay, now we're all ready to go. But we first have to cut down our forest. I'm sure my arm was in the way that whole time, I bet. Oh well. Too late. I have a pair of wire cutters here. Somewhere. There they are. Okay. Time to cut the trees down. Now if we had the smaller caps, now would be a good time to get those done. But since I don't have them, won't focus here. Come on. Focus. Oh, it's zoomed out. Okay. And that's pretty clean. And they look nice and happy, like tin soldiers. Now, I don't see any other caps of that same exact capacitance. Otherwise, I'd be replacing them. Okay, so it looks like smoke on these caps here. It's not smoke. That is dust, and could possibly be from heat exposure from this resistor down here. Or actually, no, that's not a resistor. That's a board's not labeled correctly. It's NT811S. I'm not really sure what that is, but these generate heat sometimes. That's not a resistor though. I think it's a capacitor. I should know, but I don't. Yeah, these are caps down here. NT, what would that be? NT. I don't know. Nevertheless. So we've replaced those for... Let me look at my stash and see what I have. I don't think I have anything close to this. 50 volt 0.47, or yeah, it should be 47 microfarad. Let's see what I got. I'll give you a close-up look at these old caps. They're all domed, except for that other one. So they're no good. Okay, I just booted up my video source. We're going to get ready to power test it. Okay, here we go. It should turn itself on. Or not. There it goes. Okay, backlight's up. Image hasn't changed. So this confirms that our T-con board is bad. Chances are those little caps aren't really causing that much trouble. They may cause some electrical noise, but we really don't know how they work in circuit yet. So I haven't seen a diagram. But those 4 caps are doing their job. We have to continue on and replace the T-con board. So we're going to take off where we left off as soon as the part comes in. Stay tuned. And now we're at the awkward end of the video where it's going to kind of leave on a cliffhanger. We're never going to know how well this TV works. And here's why. So the TV is sitting right here. And judging from the snow on the ground, the video was actually filmed in January or so. I believe it was January, shortly after that turn of the year, shortly after the new year. And it is, judging from the fact that my fan is running full bore, it is actually well into August. It's actually August 1st. Saturday, August 1st, 2015. So here's what happened. At the time I began this project, my sister needed a television. That's what the whole purpose was, of acquiring and repairing this TV. I wanted to help her out. She just had a kid, and she got her first apartment, and she's moving forward in life, and I wanted to give her, a nice little housewarming gift. Well, it turns out She was working for Burger King at the time, and they gave her one of the TVs that was in the lobby, or in the dining area, that was starting to fizzle out, they claimed. They say that the screen was getting dark. It was a 42-inch LG, and I found nothing wrong with it. I mean, it's not brighter than the sun anymore, but it works fine, and it's been working fine for 8 months. Well, couple in the fact that when I ordered this to be replaced, I ordered the replacement part on eBay. It came from Hong Kong, and I got this. You know, it kind of set me back, because now I have to either send this back for a refund. Now that means I have to ship it to Hong Kong, and that'll take a month, or just simply pony up another $40 some odd and buy the correct one. At that point, I lost all real drive to finish the project, and the TV is still sitting in the same spot it was 8 months ago, waiting to be finished. And there it is. And that's pretty much it. So the project has never been finished. I mean, of course, we power checked it. The power supply is working great. The screen is great. Everything is good, except for this VC control board. And although it comes, the more common name is, and I'll think of it in a minute, but forget it. You'll already figure it out because it's in the video 100 times. But we need to replace the board again. Until I find a use for that TV, I'll probably just let it sit there, and maybe I'll end up throwing it out again. I don't know. I don't want to throw it out because it's fixable. But I just don't want to put the money into it right now because I don't have any use for it. I have 4 LCD projectors that I can't find a use for. But, you know, maybe when I get a bigger house, I'll have things set up a little differently. I'll have media centers everywhere and TVs all over every wall. But, you know, I don't really have much wall space. I could put a TV right there, but then I have to run power to it, you know. So, really don't have any need for another television in this house. That's why I gave away my 42-inch plasma that was up here, the one that I got for free, and put, I don't know, 120 bucks into, fixed it, gave it away. Because I don't need more than one. So that'll be the conclusion, the cliffhanger ending to this video. Will it work? Stay tuned. Maybe in a year or so, I'll have it fixed. Until then, have a happy, I want to say Hanukkah, but I'm not Jewish, and it's not exactly Hanukkah, so have a